but it's always a good opportunity to just put everything back together, you know, just make it organized. And I'm joking about you learn nothing. I think you will learn a lot. Yeah, and also important street rule is that the more we talk about tests, the less we write them. So I think it's good to talk about them a lot. The plan for today is generally to answer the most commonly asked question by the managers: why the hell we need tests at all? Then I think we will overview some basic test flows that are healthy, and just generally I collected all the good tips about stuff I learned during my time working with the tests. Then we'll go through some popular testing definitions because I think there's a lot of important definitions that you will probably use a lot, but maybe you don't know actually what they mean, or you will be surprised what they actually put in common. At last, I will recommend you guys some tools because I think there are a lot of them that I actually make a job done, and maybe you will know them. So I wonder, will you use them or something like that. At last, I will share you with some tips and some summary, right? So why I do feel entitled to give you this talk? I coded with Flutter since 2019, and during that time I seen and code myself stuff that are beyond imagine how disastrous there was, and how actually tests and adding tests to my repository helped to improve them. And currently I'm working at the company that tests a lot, and tests also on users, right? So because we do not hire any QA, so all the responsibility correctly is put on the developer's shoulders. So we need to put a lot of effort to automate tests and make our code as much reliable as possible. So I will share you some lessons learned hard way on that matter. But before we jump into interesting parts, let me read you the definitions. What is the software testing? This is the process of identifying the correctness of software by considering all attributes and evaluating the executions of software components to find the software bugs or errors or defects. This is literal definitions from one book about software testing, which is this big, right? So put in simple words, it's just software testing is the process of verifying that software product does what it's supposed to do. There is multiple ways to assert correction of your software, and two basic types are functional testing and non-functional testing. The functional one is based on the business needs, right? The business requirements. This is something that business puts into Jira tickets and so on, right? To do, right? And then you have non-functional, which is what users expect that this software will do, right? So non-functional testing is about what the business cannot predict, and naturally the non-functional testing is in scope much more bigger than functional, right? And what is really interesting about that part, that non-functional testing is or should be automated, right? So this is the interesting part, because you cannot do those tests like security, volume, UI in manual way, right? Because you need to hard output of the results, right? The functional on the other side, you can be done manually, but it's also a hectic task to do. Definitely, what is supposed to be is you should automate your old test suite, and based on that, assure correctness of the software. Important part also is like both of those type of tests can be done in white, gray, and box testing, meaning that you might know. The white testing is like I know what is inside the box, right? And the black box is I do not completely what is the logic that results in specific output, right? In this presentation, I will focus mostly on the functional testing because this is what the developers will most of the time spend most of the time actually testing. So let's answer the question why even bother, right? As soon as you will start writing a test, you will see that tests are improving the app structure. Messy code, messy architecture is more difficult to test, right? So you will actually need to adapt and refactor your code in this manner that it will enforce your app architecture. When you will start writing tests, you will also see that your way of thinking will change, right? You will think in the manner, how can I keep this simple enough to test it, right? And this will simplify your thought project. You will try to less write complex logic. You will learn the rule divide et impera that will ease your test to make it work at all. The tests are the only way to verify if the code works, right? How much you are confident that your code works and does not break any changes, right? The test will assure that. Because when you run the test, you will have this green light that, hey, this whatever you wrote, right, that did not broke existing code and you are good to go. Next, this is the follow-up to the previous point, right? You don't have to look through huge number of Jira tickets, right? In your management tools, right? Because there is a lot of tickets that you will have describing some requirements. They are all hidden somewhere there in some confluence, right? When you have the codes, when you have the tests, then you will have one place then with written all the requirement that is written in domain language, meaning the types, objects, methods, and so on. This is actually the language that you and your team will understand. And the last thing, I guess, this is much more faster than black block testing, and by black box I mean manual testing, meaning, hey, I run the app, I download it from the test slide, go through every time, every feature, and maybe it works, maybe not. Will I cover all the edge cases and so on, right? So this is the, without a doubt, money and the time saver. You cannot compete, manual testers cannot compete against the automated tests, right? And I think this is maybe a little bit neglected, that tests make you a better engineer at all, right? So all these bullet points are summarized into one. This is by writing a test you are just better. And how the whole testing process looks like. Usually, let me get this amazing tool. Basically, you write some code, right, and then you write some tests, right, or the other way around. But this is generally the starting point, right? So you write the code, you cover it with the tests, and if they fail, right, then you go back to the previous point, basically, right? And if we all agree, right, then we ship it. right? This is, let's say, our starting point of, hey, we are good to go. And what happens when naturally something breaks on production, right? We occur on the bug fix. So we get back to the previous point. We are writing a test for that specific bug. It fails, right? We develop the fix for that, and when we are actually good to go, then we ship it again. And then we back to the first point when with the every new features, and we repeat whole process with the every code change. And how healthy test structure looks like. There are two things like testing pyramid and testing ice cream. And generally what they are describing is that the structure of the tests or in your software product. You start, your foundation should be automated unit tests, right? The tests that are the closest to the specific code. Then on top of that, you are adding widget test in Flutter. You are adding golden test if possible, and just on the top of this pyramid, you add integrations tests because usually it grows in the complexity. On the other side, you have the anti-pattern, the testing IceComp, which is sadly the thing that I met most of the time during my professional career, right? So we are writing tests, we are delivering as fast as possible because the clients have tight budget, and we cannot just add more quality. We are hiring a bunch of testers, especially in software houses, that they are doing a lot of manual testing, and if they are skilled, then we are in luck because they probably get some Appium, maybe some Gherkin, and then they will add some tests on top of that. But generally, our whole core is their manual labor. So generally what we should do is avoid the IceComp. We should add more unit tests because they are designed to, in this manner, to break often, to get us information, hey, something is not doing as expected. And generally, as you can see, this is a trade-off. Why we have a lot of unit tests instead of a lot of integrations tests? Because unit tests are fast in execution time, amazing ROI on the time spent on writing code and the quality we are getting back. And the more integrated tests we are adding, and they are failing because of some minor issues, then we are spending time on debugging them and investigating what actually made them wrong, where the regression came in. So they have high fragility. That's why it's not like we shouldn't have them. It means that we should have them less. And let's say some testing manuals will say your test suite should be about 70% unit test, and in that manner it should be like another 20% of widgets test, of integration test, and only 10% should be it should be your times working on with manual testing, right? And next I will tell you about the test-driven development and behavior-driven development, and please see that you have it should be both.
Sorry, it seems like the camera is
ignore it. Okay. And what I just wanted to say is that they should be working together, not separately, because usually on some medium articles you will find test-driven or driven development or behavior-driven development. It's not like it's this or that. This is like behavior-driven development is like the next iteration of test-driven development. They work extremely well together. And let me tell you about the TDD. This is really interesting because described by Martin Fowler. This is from his blog. Test-driven development should start with your preparation about the list of the test cases, right? From that, you pick one test, right? You write the test in so it fails, right? For example, it's not doing what the requirement says, or it's not just you are missing implementation. Then you make it pass, right, by writing a new code or refactoring the old one. And then you clean all the stuff that you wrote in that manner that it should still pass, right? Then you pick another test, right? And then you repeat the process. All of this can be summarized as a red-green refactor, right? And what is also important, we update those lists of the test requirements as we go. And what is also important in this technique that maybe it's not often mentioned, that you should follow this pattern in this way, so with the test and the requirements, that you are as fast as possible at the point of feature finished, meaning that you don't write the whole extra logic. You know, we covered the happy path, for example, the test-driven development, and then you go further. Right, and to sum up, test-driven development is really aggressive in terms of meeting the requirements. So what I mean by aggressive? When you write tests before writing actual code, right, you are thinking forward. Because, for example, what I often do myself is that I write tests in the defensive way, meaning, okay, I'm tweaking a lot with the development, right? I'm clicking on throughout the app, and then I'm writing a test coverage for the specific feature. And this is the defensive behavior, meaning that I might sneak some bugs that I did not think of, but because I write the test code in a specific way instead of covering the specific features. But does this mean I should resign from test-driven development? No, because some tests are better than zero tests, right? And this is the approach I had for the long time, and this would get me going, especially that if you're covering the core functionalities, right? Because what the problem is that covering your repository at 100% level is often like some kind of street legend. You can because we cannot fool anyone. We need to deliver functionalities at the end of the day, and this is the trade-off that we are having with the budget and the management. What also I found that is working for me is that I write some tests to established code, meaning that it's survived untouched for a few sprints, right? And then maybe it's a good idea to get back to this. If this works, don't let the changes to introduce. Let's write some tests to not introduce new stuff for the established pieces of code. And regarding the BDD, this is the place where the product manager and developer meet to discuss the user stories and come up with the concrete actions to do, right? And with these actions can be converted to specification that makes everyone being on the same page, right? And BDD combines the techniques of TDD, meaning that we are preparing the list of the features, right? Then we are writing the tests that are failing because we are missing some requirements, and then we are getting back to the specific to the new features, right? And yeah, as I said, we define the behavior of the software, we write test and describe the specific behavior of the software. We write code and then we refactor code or to improve its quality. So what makes a good test, right? First, good unit tests are isolated and independent, meaning that they are testing one unit, meaning what you have one assert, one expect, and this is something that I also kind of try not to broke, meaning that we are writing tests that often I'm validating multiple stuff at the same time, right? Because it's easier. We have okay, by this time I will check something else. So we shouldn't do that because we will couple them together, right? We'll not get the same test coverage. Next, good test is descriptive and clear. At the first glance, I should be able to know what is the expected output and what I'm actually testing. What can help you with that is establish some specific naming conventions, right? So, for example, at OLX we are using the should do something when and what I'm doing, right? So this helps with at least writing a good test descriptions. Good tests are repeatable and fast because they need to be designed to run often, and we cannot spend a lot of time waiting for the output of the test and compiling everything. And then good tests shouldn't be ignored, meaning this should be commented. This should not be skipped. If the tests are failing, that does mean you should fix it. Because if they are not addressed, then this is just a boilerplate code, that code that you have in your repository. And then good unit test is well structured, meaning that it follows arrange, act, assert. And what does this mean? This means that we have arrange. This is the first phase of the test where you are preparing your code to be tested. You are configuring some, for example, dependencies. Then the second A is an act that you are actually calling the code that is being tested. You are capturing the output, and then you are asserting the result, right? Meaning that 2 plus 2 is 4, right? And this should always be 4. And this is, for example, example from our code base where we are checking the conditions to display some label, for example, about if there is a specific transaction type and this is not null, that meaning that the offer has price on it, then we should, for example, have some specific output, right? This code should be under this condition should be always be true. This is the similar test, but written with the block test. And for example, I assume most of developers here are working with the block test, right? Someone else using signals, Riverpod, please raise your hand. One brave. Okay. Then probably if you are, what you are working with Riverpod?
Yeah, with Riverpod.
Okay, so you know probably that how difficult sometimes it is to test with the Riverpod.
Yes, sometimes.
Sometimes. Okay, so in this previous slide we had some objects appeared that you might stumble upon on. I mean mock, fake, stub, or dummy. This is like the terms, technical terms for the testing. And general term for those are test doubles, right? And funny thing, if you try to translate in Polish, like meaning how do I call this in Poland? This is a doubler. And this is like when you, for example, read a book about testing in written in Polish, the doubler, right? This would be what the general term for those. And regardless of the name, the simplest form returns the prearranged responses. And this is the screenshot from Wikipedia. about the definitions of those, and you can see that are not consistent across the literature, and you have 6 positions listed extra, right? Meaning that this is the books that are not consistent about that. So generally, when I try to like get to the bottom of these cases, the stub is the anything that help your test run and make it pass, right? Stub cannot never fail. This is like the most general term for other terms, and the most popular one is the mock, and mock is will help you to isolate unit from the dependencies, meaning that you will isolate your code from, I don't know, the API, right, network calls, or from your database, and with mock you just mimic their behaviors, right? Fake is both mock and stub. This is the faked but working shortcut implementation to mimic something, right? Not suitable for production. So for example, you write some fake implementation of, like, I don't know, network code, right? And you have some class that you don't inject in your production code, but you consider it handy and you are using it for the testing. At last, it's dummy, and dummy just is the object you pass around, right? So both of above are true for the dummy, right? So for example, you inject something, I don't know, you have some concrete value, and just for example, you want to return a list of items, and this is dummy. And I would like to recommend you some tools, and probably this is the most popular among you, that's the mocktail. This is like offers the same, the main benefit over Mockito is that you don't need generated code, right? So if you don't use build runner, you can use mocktail, and it's really nice because you offers you whole API for stubbing and for logging invocation, and have some argument matches that are really useful. So if you are using Mockito, it's fine, but just with that you can save your time on build runner and generating mock files. Another one is a matcher. Matcher is, I think, the part of Flutter testing suite and SDK. And with matchers, you can support complex validation, meaning that you have some multiple conditions that needs to be made. And this is generally something that is useful, as it is more flexible, more descriptive if you want to check some complex validations. And on your right side, you have a cheat sheet with a lot of matchers. So if you look on the online assertions in Dart, you hold files created by Anna Leszczenko. I hope I pronounced that right. And this is a really good lecture to just find. Another one, with the golden toolkit being deprecated, and I'm doing air quotes because it was being as deprecated as it's being migrated to the core Flutter SDK for the test. You also have the Alchemist, which provides you the API for the golden test that you can capture images and put them to the code. What is good about this package? This is the written in cooperation with very good ventures and the Betterment. So this is like, let's say, reliable publishers that we can trust and we can use their code. It offers CLI and extensive documentation, and I think it's really good things to mention. Especially that it's also easier to set up than adaptive tests. And this is subjective, right? So if you find Alchemist more complex than adaptive tests, then we can agree to disagree. Another one is a faker, and just class that is inspired by some Python library to generate fake data, and it creates dummies for your test, right? And here is, let's say, community validation. It's not like I'm saying this is good, let's use it. This is example of golden test from the Alchemist, and the faker being used by girl Very from I think it's either south of Germany or Austria. I think South Germany. Yeah, and she created the app for drummers, I guess, to learn, and you can see that she made a golden test with the faker, and it works pretty well, especially that if you do not want to write ID and put value 1, for example, right, when you have some, I don't know, numbers. Another one, probably there is no person here that doesn't know Patrol, right? That's good. This is also established solution in community. It offers CLI and have a really good documentation to work with, and probably is the best solution that we have currently for the Flutter. And yeah, the most popular thing I heard the negative about Patrol is that it's really difficult to set up for working for iOS, right? Maybe it will change, or I'm doing something wrong. But yeah, that's something that is really well known, and also it really works with the Flutter test lab. We set up in OLX ourselves as well. Yeah, I will get back to this one later on. Another thing that in terms of the integration test that is hugely growing is the Maestro. Who heard about the Maestro? Okay, you have native backgrounds? Those who raise your hands.
No.
Yeah.
Oh, okay. I'm mentioning that because it lately got support for Flutter, because this is well-known SDK in native Android and native iOS. I think also for the web, but generally lately they had SDK for the Flutter. It's going pretty well, so this might outgrow the Patrol in the terms that we know it, especially that the syntax for it looks like a Honey. And the Honey was like some kind of tool or framework for also written the manual test. And it works on the semantics labels to discover what we are integrating with, and thus I think in comparison to Patrol doesn't require constant rebuilds of the app, right? So we can work on the same instance of the app. Another thing I would like to recommend, or at least to try it out, is a BDD widget test. So how it works, based on the feature files for Gherkin, you write those files and it generates code for you, but there is also a trick. It only generates the empty test suites, so the implementation you need to write on yourself. Good thing is that the more tests you write, the more steps you have to already built in, so later on it's easier to write more complex tests. But the entry point I think is really difficult. But what I liked the most in that package was that it has really good tutorial on YouTube recorded by the creator of the package. And it worked really nice if you would like to get into it. And if I had tell you about the integration test, maybe you heard about the robot pattern. If not, this is how we test our code in OLX. It generally works as in this BDD pattern, meaning that we are writing robots that allows us to perform some specific actions, right? And basically what is happening is that with Patrol we are creating just tap on that specific key, for example, and we have whole step ready, and then we are reusing this code in some actions that need to be repeated. And it works really well if you would like to create with the Lego bricks more complex actions, meaning that, for example, we have filling the contact form, meaning, hey, I would like to buy this property. So we have fill contact form is based on few other steps that need to be done, and then we just can go back to specific action, right? Again, so this is by applying Lego mechanism, we can go really long way. Yeah, another thing with the integration test is our widget tests. And what I like the most about widget test, this is like in the middle of this pyramid, meaning that if we put a little bit more effort than writing unit test, we get really good coverage. And we are as a front-end developers, write mostly the UI code, right? So this is like the main point of all of this. And with a lot of in this test, I would like to don't mind that there's a lot of excepts, which breaks the good patterns. But I would like to point out that you have a lot of finders that can go really well, meaning that you can find widgets by type, you can find the specific widget of the type of the text, you can try to go with the predicates and go deeper in some kind of evaluation. For example, we would like to test that add node text is of the specific font size, or this colored box has specific background. So the matches, I will help you verify the widget properties, and this is actually the purpose of the widget test. And because we are not living in the Stone Age, we can use AI to automate our work, because no one is trying to sell you some bullshit that writing tests is all pleasures, right? This is usually the daunting task. But this is the command I usually use, meaning that I put some class, right, and then to it, and actually gets the job done. Usually the problem is because you need to verify what the AI put in. So you do the code review on the AI, and you can verify if that actually get the job done. Yeah, but help yourself. So generally, accept what I would like to tell you is accept that without the tests, the tasks aren't really done, right? By forcing yourself to write tests, you will ask the stakeholder, hey, what is the outcome? What should happen, right? And that will help you document the list of the requirements, right? Also, as I said, there are three kinds of tests: the unit, the widget, integration. The unit one is the cheapest to write, give you the most comfort, and give you the opportunity to actually verify if your code works, right? Then you build on top of that. Another good unit tests are fast, focused, and simple to read. They have a good description, right? They are designed to be run over and over again. That's why they need to be fast, right? Use code coverage to spot the not tested code, right? We actually have, this is a really good tip, so this is something I would like to recommend to all of you. We use the Flutter, Firebase pages, right, to build and post the code coverage online, right? So we do not have to build it ourselves, open the index, just like we go www.auto.dom/tests and we have actually the latest code coverage, and we can find what actually is not tested on the develop or our own specific branch. Test needs to have the assertion, because this is also important. Sometimes there was the cases I spotted the tests that are testing a lot of stuff, but they do not have any except, right? Test coverage doesn't tell you that. This is something that you can write test, it runs, but you don't never check the output of the test. This is really important to be mindful. Using the group API, you can gather the tests that are testing the similar logic together. Groups also offers you a specific API, for example, to skipping some group of tests and so on. Or for example, you can write on group on multiple inputs, right? So for example, you have list of strings, and for each string you're running the whole group. So this is also useful. As software development is a complex process, as we all know, there is no one size-fits-all solution, and the whole challenge is to balance our output versus the code, right? Sorry. Yeah. don't strive for the 100% code coverage, right? This is not something that we would like to have. I think if you are on 50%, you are more than good, right? I rarely spotted the repositories that have more. If you have more, raise your hands. Man, congrats.
No, we had more, but at the time we just used ignore test.
Okay.
Yeah, because
Yeah.
we had like the goal to make 100% coverage, but the client wanted to deliver fast, but also he wanted to have this code coverage.
Okay.
What to do?
Okay, I understand. Yeah. See, no one in this room actually had reached the best I had is currently, I think we have at all like 70% code coverage, right? And we are battling every day to get more and more and more. Yeah, is your workload with the AI? This is a tool, and if you are not using, then you are missing out. Also, what I've found, I think interesting, that you can run your widget test on the devices, and sometimes I found it useful that I can see actually what I'm missing. For example, I will have some finder looking for the text that was off stage, it wasn't visible on the device. So with the Flutter run widget test file, I actually could spot it and help me out. Also, Dart test allows you to speed up the test by running it on multiple threads. You can also randomize the order of the test, meaning that, for example, you can test if your tests are actually isolated. This is something. Another point is something I learned on the Flutter Cracow meetup from people from Poznań. They told me that you can contribute your golden tests output files to the merge request, and actually you can see easier what the changes are being made. So, for example, for the new function you have golden test, you don't have to even validate it, but you already have some tools that give you the screenshot, and you don't have to write comments. Hey, can you put the image what are actually the output or something like that? Yeah, something very useful. Another thing, create a global testing util method that mocks your app entry port to inject whole navigation and localization and theming. So, for example, every time you do pump up and you're writing some material app, this is bare bone, right? So this is nothing useful for you, especially if you have text styles injected, if you have your app in multiple languages, and for example, if you would like to use even navigation in widget tests, right? For example, you put, I would like to test if after tapping the button I have bottom sheet up, right? Or something else, and without specific navigation, specific widget for that, we cannot do it. And when you don't respect your tests, there is no point in writing them, right? So if you write them, you need to run it, you need to include them in your CI, and just use them. And this is my closing remark for you all, right? Whenever you are writing tests, don't tell your boss, because the managers or clients might not understand the whole concept behind it, right? This should be your responsibility. You are doing it for yourself to prevent you from doing stupid mistake in the future. Yeah, and that's all. Thank you for coming today to listen my presentation. I will be happy if you could provide me some feedback on this presentation, if you like it or not. And yeah, thank you.